will offer with more lower price. Meanwhile, for the rising delivery cost, is based on the reducing in the transportation cost as as increase in the uh, volume of order. So value total cost curve in practice normally a sliding scale of unit cost applied so that where every unit bulk has a different price. And frequently the unit cost decrease in step with the supplier offering a reduced price on all units if more than a certain number are bulk. There are two main characteristics of valid cost curve. The valid total cost curve always rise to the left of a minimum, and there are two possible positions of the overall minimum cost, either at valid minimum, or cost breakpoint. So there are two position of uh, valid cost curve here. First is about the valid total cost curve, where always at the left of the curve with the valid minimum. And if there is no valid minimum, we will find the cost breakpoint or the solution. So valid minimum, the minimum point on the cost curve is within the range of valid order quantity for this particular unit cost. For example, if we analyzing the order quantity should be 100 unit, but our aim is to get the lowest price from the supplier, and supplier offer, for example, if we buy more than 100, then we can get price per unit at 50 cent, for example. So we need to increase the order quantity more than 100 unit in order to get the lowest price. So this condition is under the category of invalid minimum. So to understand more practically, let me see the example of quantity discount. For example, here we have a quotation price from our supplier where the price is decreasing based on the increase of quantity order. For example, here we have, if we order 1 to 49 unit, the price will be 1,400. If we buy 50 unit to 89 unit, so the price will be at 1,100. And if we buy more than 90 unit, the price will decrease to the 900 ringgit. So we also have provide about the information ordering cost, CO, ordering cost 2,500, and carrying cost per unit is 190. And we know that the demand is 200 unit. So for the first step, where the carrying cost, we have information about fixed carrying cost. So the first step is to determine what is the optimum order quantity. What is the optimum order quantity? Based on the data that we have, the optimum order quantity is 72.5 unit. 72.5 unit. Where the result from the square of 2 multiply with demand multiply with the ordering cost divided by carrying cost. So we have 72.5 unit as an optimum order quantity, as an optimum order quantity. So based on the optimum order quantity of 72.5, we need to identify the 72.5 unit here is fall within the which range in the quotation price provided by the supplier. So we found that the 72.5 unit is between the range quantity order of 50 to 89 unit at the price of 1,100. So for the queue of 72.5 unit, the total cost for this quantity discount model will be 233,784. So we need to calculate what is the fixed cost and what is the variable cost in order to determine the total cost. So of course, in the quantity discount, to determine what is the best quantity order, we must include the fixed cost in calculating the total cost for inventory control. So here, the formula for the fixed cost is price per unit multiplied with the demand per year. So 1,100 multiplied with the demand 200, we get the fixed cost. We get the fixed cost. So fixed cost is whatever order quantity that we buy from our supplier, this cost we incur to the company. We need to pay this cost. And for the variable cost, which is ordering cost and holding cost, and this cost is changing based on the quantity order, So if we order at quantity of 72.5, so the ordering cost will be 2,500 multiplied with 200 divided by 72.5 and plus with the holding cost 190 ringgit per unit multiplied with 72.5 divided by 2. So we have the total cost of 230,784 ringgit. So the next step is to consider the lowest price. So to consider the lower price based on the quotation price here. So the lowest price at Q equal to 90 unit. Q at 90 unit. So the price for the Q equal to 90 unit is 900 multiplied with the 200. So we have the fixed cost of 1,800. Sorry, 18,000. And for the ordering cost and the carrying cost, 2,500 multiplied with 200 divided by 90 unit plus with the 190 multiplied with 90 unit divided by 2. So we have 194,105. So we have point B here with the lowest total cost compared to the quantity order of 72.5 unit at point A. So to conclude, we choose a quantity order of 90 unit which provide a lowest total cost compared to the point A with the quantity order of 72.5. Okay. Why do we not include the price of 1,400 with the quantity order of 1 to 49 unit in our analysis, because as a rule of thumb here, if we include this price in our calculation, of course, the total cost for this quantity order and price will provide higher compared for the both of point A and point B. That's why it is not necessary or has been excluded from quantity discount analysis. So this approach only apply for the quantity discount model with the fixed carrying cost. With the fixed carrying cost. Okay. Any question before we proceed to the next example where we find more complex of quantity discount analysis. Boleh faham kan quantity discount? Dah belajar dah ni kan. Masa production operation management kan. Banyak yang dah belajar. Dalam subjek inventory management ni banyak yang dah belajar. Boleh?
Sir, Sir record ke belum?
Allah Akbar. Nasib baik kamu cakap. Saya akan record sekali ni ya. Okay.
Okay.
Okay, I always forgot to record this class. So today we are going to discuss about the deterministic model inventory control. Under the deterministic inventory control models, where we remove some of the basic assumption, especially in the economic order quantity, where in the basic model of economic order quantity, the value of variable such as carrying cost, holding cost, demand from customer, and all this information in the basic model of economic order quantity is known. But for under the deterministic model, some of these assumption has been removed to allow more flexible application of inventory model to support the organization policy or inventory management policy. So under this topic, we will discuss about the quantity discount model and also production or the quantity or finished replenishment rate model. So under the quantity discount model, we will discuss. There are two techniques that we going to apply in this topic, which include the total valid cost curve and rising delivery cost. Total valid cost curve and rising delivery cost. For the total valid cost curve, we only discuss on the quantity discount model, and under the quantity discount model also have two approach to solve the problem with the quantity discount model. Quantity discount model is applied when the supplier provide a quotation price changing in the price per unit based on the quantity order. The more we buy from our supplier, the lower price will be provided by supplier. For example, here we have a quantity discount data here. Supplier provide information with the quantity unit 1 to 49 unit at the price of 1,400 and 15 unit to 89 unit with the price of 1,100 and 90 unit above with the price of 900 ringgit. So as we can see, the larger amount of quantity we order from our supplier, the more price will be decreased. And we also have information about the ordering cost at 2,500 and carrying cost at 190 ringgit per unit and demand at 200. So at the first step of the quantity discount model, we need to find what is optimum order quantity. The formula for optimum order quantity is square of 2 multiplied with demand multiplied with ordering cost divided by holding cost. And based on this formula, we found that the optimum order quantity is at 72.5 unit. So based on this optimal order quantity, we need to find the order quantity is for which range in the quotation price provided by supplier. So in this case, 72.5 unit, it fall between the quantity order of 50 to 98 unit at the price of 1,100. So the next step is calculating the total cost of inventory. Total cost of inventory, we need to include the fixed cost, where is price per unit multiplied with the demand. So 1,100 multiplied with 200 and plus with the variable cost of ordering and holding cost. So we get the point A at 203,784 ringgit. And the next step is to calculate the total cost for quantity order of 90. Why we need to calculate the total cost for quantity order of 90? Because as the quantity discount application is to get the lowest price based on the large volume of order. So if we increase our quantity order to 90 unit, we can get a lower price at 900 ringgit. So based on the formula of total cost for the quantity discount, we find that the total cost for quantity order of 90 unit is 194,105 ringgit as a point B. And why we are not include the quantity order 1 to 49 unit at the price of 1,400, because this price unit or the quantity order is exclude from our analysis, as the optimum order quantity is at 72.5. Okay, so any question for the quantity discount before we take break for about 5 minutes? Kita rehat sekejap ya, 5 minit. Saya ada benda perlu saya buat sekejap. Ada soalan sebelum tu? Nanti kembali selepas, after we back after 5 minutes, I will answer your any question about the quantity discount model. Okay. Any question about the quantity discount? Have you seen my, I'm moving the cursor. Have you seen the cursor move at the slide?
Yes.
Okay, thank you. So let me see what we have on next example of quantity discount. Okay, this is more interesting data for the quantity discount. Quite different from the previous data. Where the holding cost, as you see here, the holding cost is at 40% of unit cost. The holding cost is at 40% of unit cost. So this means that the holding cost is changed based on the unit price. Based on the unit price. So compared to the previous example that we discussed before, the holding cost is fixed at 190 ringgit, right? But for this example, the holding cost is fixed at, the holding cost is changing based on the unit price. So for this example, the step that we use in the previous example is not applicable. It's not applicable for this example. So, as the previous example, that the first step is we need to calculate the optimum order quantity and find where the optimum order quantity fall in the range, in which range of the quantity discount or quotation price. So in this example, it's not applicable of that step. So what we have here is annual demand for item is 2,000 and the ordering cost is 10 ringgit per unit per year, and the holding cost is 40% from the unit cost. The unit cost depend on the quantity order as follow. So this is the quantity discount price. With the unit cost of 1 ringgit for order quantity less than 500 and 80 cents for quantities order between 500 to 999 unit, and 60 unit for the quantities order of more than 1,000 unit. So we identify all the data or value that we need to be analyzed in our quantity discount model. So we listing the variable here. We have a demand 2,000, ordering cost is 10 ringgit, holding cost is 40% from the unit cost per year, and the order quantity is the cost here, the holding cost is depend on the order quantity. So in this procedure, the first step is to analyze the lowest cost curve. The lowest cost curve where the unit price, the lowest unit price is at 60 cent. Is at 60 cent. So here we have the lowest price per unit. Here is 60 cent. So we need to start with the lowest price. Why we need to start with the lowest price? Because we would like to analyze whether we are eligible to get the lowest price with the normal order of quantity from the supplier. So the unit cost is 60 cent, and this unit price is only valid for the order quantity of 1,000 or more, which means that if we would like to get the price at 16 cent, we need to buy 1,000 unit or more from our supplier. If not, the price will change based on the quantity order. Let's say we order at quantity of 800 unit, so we are not eligible to get the price of 60 cent per unit. So we need to look back at the price quotation for 800 unit price. So for the 16 unit, 60 cent here, the quantity order of 1,000 or more. And based on this value, we calculate the optimum order quantity and replace the value based on this information here. So we have here 40% here for the to calculate the holding cost. 40% multiply with the 60 cent per unit as a price per unit. So we have the optimum order quantity of 408.2. 408.2. So this is invalid minimum as Q is not greater than 1,000. So based on the optimum order quantity, show that 408 unit is not valid to buy the item at the price of 60 cent. So if we would like to get the price at 60 cent, we need to increase our quantity order to at least 1,000 unit. To at least 1,000 unit. So the value of Q in calculating the total cost need to replace with the minimum order quantity of 1,000. Okay, boleh faham setakat tu? Maksudnya macam ni. Okay. First step untuk holding cost yang berubah berdasarkan harga seunit, maka kita tidak boleh gunakan contoh quantity discount yang kita discuss sebelum ni. Kita kena gunakan kaedah yang lain, yang mana langkah pertama adalah untuk menentukan total cost bagi harga paling rendah yang ditawarkan oleh pembekal kita. Bagi contohnya di sini, harga yang paling rendah yang ditawarkan oleh pembekal kita adalah pada harga 60 sen. Tetapi dengan syarat kita perlu membeli dengan 1,000 unit daripada supplier. Sekurang-kurangnya 1,000 unit. Jadi kita kira apakah optimum order quantity kita. Sekiranya unit cost kita adalah 60 sen. Jadi kita gantikan di sini 2 darab dengan 2,000 demand per year, multiply dengan ordering cost RM10, bahagi dengan holding cost iaitu 40% daripada unit cost, unit price 60 sen. Jadi kita akan dapat 408.2 unit. Tetapi 408.2 unit ini adalah kurang daripada 1,000. Maka kita akan katakan value Q ini adalah invalid. Value Q ini adalah invalid. So untuk memastikan value Q ini adalah valid, kita kena increasekan kuantiti pesanan kita kepada sekurang-kurangnya 1,000 unit. Jadi dalam pengiraan total cost untuk harga 60 sen, value bagi Q di sini kita tidak menggunakan nilai 408.2 unit lagi. kita perlu menggunakan Q dengan nilai minimum kuantiti pesanan sebanyak 1000. Jadi kita gantikan Q dengan 1000 ke dalam formula total cost dan kita akan dapat total cost bagi kita yang pertama iaitu 1340. 1340. Baik. Langkah seterusnya. Kita akan ulang proses ini sehinggalah kita jumpa quantity order yang valid. We have to repeat this process until we get the valid minimum of Q. Valid minimum of Q. So the next lowest cost curve is at unit cost of 80 cent. Unit cost of 80 cent. So for the unit cost of 80 cent, the Q, the order quantity must be between 500 to 999. So calculating the optimum order quantity, we found that the optimum order quantity is at 353.6 unit. So this value of optimum order quantity also invalid. Also invalid for the Q for the price of 80 cent. For the price of 80 cent. Why? Why this value of Q is not valid? Because this value is not in the range of 500 to 999. Kan? Okey. Kita tengok langkah seterusnya adalah untuk membuat pengiraan total cost curve kita iaitu pada harga 80 sen dan kuantiti pesanan mestilah di antara 500 hingga 999. Dan apabila kita kira optimum order quantity kita dapati ianya adalah 353.6. Jadi Q kita adalah invalid. Kenapa invalid? Tidak valid untuk harga 80 sen kerana 353 unit tidak berada di antara julat 500 hingga 999. So, calculating the cost of the breakpoint at the lower end, total cost for the 80 cent, we need to replace Q with the minimum order quantity in the range of unit price 80 cent. So, we replace Q with 500. So, the total cost with the minimum order quantity of 500 is 1,720 ringgit. So this total cost will be a point B. The next step is to calculate the total cost of the unit price at 1 ringgit. Where the 1 ringgit is valid for the ordering quantity less than 500. Jadi langkah seterusnya adalah untuk mengira lowest cost curve pada harga 1 ringgit yang mana kuantiti pesanannya adalah kurang daripada 500. So we replace the value into the optimum order quantity here. So we have optimum order quantity of 316.2 unit for the unit price of 1 ringgit. So this optimum order quantity is valid for the price unit of 1 ringgit because 316 unit 0.2 is below than 500. So we find that the valid minimum is less than 500. So we calculating the cost at this valid minimum as the optimum order quantity is valid. So the total cost for the value of Q, so to calculating the total cost, the value of Q must be based on the optimum order quantity of 316.2 units. So we replace Q here with the value of 316.2 unit, and the next point of total cost of C is 2126.49. So we have 3 points of total cost here: quantity at 1000, quantity at 500, and quantity at 316.2. And the lowest total cost is belong to the point A with the total cost of 1340. So therefore, the best policy is to order 1000 unit with the total annual cost of 1340 ringgit. 1340 ringgit. And the placing order is at every 6 months. How we know that the placing order is at every 6 months? We just divide the 1000 divide by annual demand of kita tengok di sini apa annual demand dah. Annual demand of 2000. So we know that 2000 divided by Q, so we get the number of order per year. So number of order per year is 2. It means that 12 months divided by 2, we have 6 months. So every 6 months, we need to place an order of 1000 unit. Okay. Let's say at this point, let's say at this point, the unit price of 80 cents, when we calculating the optimum order quantity and the value is 550 unit, for example, the value of 550 unit. Let's say if we calculating the optimum order quantity here is 550 unit. 550 unit. So mean that the optimum order quantity value is valid for the price at 18,000, because the optimum order quantity here is fall in the range of 500 to 999. So in this case, the price unit at 1 ringgit not need to be analyzed. Under the quantity discount model. Baik, sekiranya katakanlah kita kira optimum order quantity, kita dapati bahawa optimum order quantity pada harga 80 sen adalah 550 unit. Jadi 550 unit ini berada di antara 500 hingga 999. Maka kita tidak perlu lagi kira bahagian ni. Kan? Tak perlu lagi kira bahagian ni. Sebab secara automatik unit price pada RM1 kita akan exclude, kita akan keluarkan daripada analisis kita, kerana secara automatik ianya memberikan kos yang tinggi berbanding dengan total cost kuantiti pesanan yang lain. Boleh Baik, saya contohkan lagi. Saya bagi contoh bagi kamu jelaskan. Contoh, katakanlah for the first step, we calculate the lowest cost curve at 16 cent. Katakanlah untuk langkah yang pertama kita kira total cost pada harga yang paling rendah iaitu 60 sen. Tengok kita kira optimum order quantity di sini kita dapat 1100 unit. Kan? Kita dapat 1100 unit. 1100 unit adalah nilai yang valid. Valid ni maksudnya kita layak untuk dapat harga 60 sen. Kerana kuantiti pesanan kita adalah melebihi daripada kerana kuantiti pesanan kita mencukupi syarat yang telah ditetapkan, iaitu dengan pembelian 1000 unit ke atas. Kan? Jadi, apabila langkah yang pertama kita dapati nilai kuantiti pesanan kita adalah valid, maka semua step yang kat sini tak perlu kita analyze. Kita hanya berpandukan kepada jawapan di sini saja. So, there will be no comparison of total cost. Okay. For example, if we calculating the optimal order quantity for the first step in the quantity model, quantity discount model here, and we found that optimal order quantity here is 1,100 unit. So of course, 1,100 unit quantity is eligible to get the price at 60 cents as we buy more than 1,000 unit from supplier. So in this case, the next lowest cost curve at price of 80 cents and at price of 1 ringgit, we automatically exclude from our analysis. So all deduction to determine the order quantity will be based solely on this analysis. Okay, boleh faham Ada soalan? Any question? No, sir. Okay. Saya harap bila kamu kata tak ada soalan tu, kamu faham kan? Maksudnya kamu faham kan? Walaupun kita agak terhad daripada segi perbincangan kita berbanding kalau kita adakan kelas secara bersemuka kan. Kalau bersemuka selalunya kalau dalam kelas saya akan conteng dekat whiteboard tu lah kan, saya akan conteng kat whiteboard tu kan lebih jelas. Cuma secara online ni kita equipment tu kita kurang untuk kita buat secara live macam mana kita laksanakan seperti face to face dalam kelas kan, masih lagi terhad. Baik, ini contoh yang samalah kan. Ni dia bagi contoh yang kedua, aplikasi model yang sama. Saya rasa saya akan stop sampai sini dahulu lah. Saya takut nanti banyak sangat kan. Nanti kamu pening pula kan. Boleh, kita stop sampai sini saja. Kita berhenti awal. Kita sikit-sikit kan. Boleh And quantity discount model, we focus at the changing of the transportation cost or more in general is where the application of quantity discount affected by the carrying cost, affected by the ordering cost, Okay, that's all. For those Muslim, we end our online class today with Surah Al-Nas. Ya. Ha? Midterm ke final? Midterm ke test 2? Test 2 kan? Oh, okay. For test 2, normally the question is quite similar with the final exam. The contents will be quite similar with the final exam. So we just change the name final exam with the test 2 because for the online class we are not allowed to do the final exam based on the ISO 1000 ISO 9000. So we are not allowed to do the final exam for the online class because when we do the final exam, it must be face to face. The student must be in the hall to take the final exam. But for the online, so we change the name to test 2. Is it clear? So just assume the test 2 is your final exam. Jawab tak soalan tu? Kan? Kamu biasa tu, kamu pernah ambil soalan final exam kan? So there will be a structure question and also uh, calculation for the test 2. And of course, the format for the test 2 might be include a case study. Based on the case study, then you need to answer the question based on the given case study for the test 2. For the last, normally it takes about same as the final exam, 2 hours and 2.5 hours plus with the preparation for to start the test 2 and preparation for submitted. So all of duration for the test 2 might be 3 hours. Include the preparation to start the test 2, include the preparation of submitting your test 2. Okay, biasanya 2.5 jam lah macam kita final exam kan, tapi sebab online jadi dia buat tambahan masa untuk preparation kepada kamu. Kamu nak set up, macam saya pun saya nak kena set up, tapi tak pun kamu buka je kat situ, saya tak perlu set up sangat. Kamu lah kena set up, kena bersedia apa yang perlu kan. Kemudian dah siap semua, dia ada allocation of time untuk kamu submitted kan. Kamu kena scan, jadikan dia file sebagai file PDF kan, supaya mudah ikut turutan untuk semak-semakkan markah, jadi baru kamu akan hantar. Lepas tu dia ada allocation time untuk preparation dan juga submission untuk test 2 tersebut. Lepas tu dia tak exactly 2.5 hours lah, dia akan jadi mungkin 3 jam, 3 hours. Okay, boleh. Okay. Baik, ada lagi soalan? Oh, saya tak bagi lagi ya. Saya tak bagi latihan, saya tak bagi tugasan kumpulan, tak bagi tugasan individu. Saya nak kena bagi kuis kepada kamu, kan? Minggu depan kita boleh buat kuis tak? For the next week, can we do a quiz 1 for chapter 1 and 2? Boleh tak? It's only take 10 question of multiple choice. 10 question of multiple choice. I will announce in the group WhatsApp for the quiz. Okay ya? Boleh ya? Okay, saya akan announce lah. Kita buat hari Khamis kan? Kalau buat hari Ahad, nanti ada yang terkejut kan, sebab ada yang dah live meeting ni kan. Nanti terkejut pula hari Ahad. Tak apa, saya akan buat hari Khamis. Nanti saya akan announce sekali lagi dalam group WhatsApp. Semua ada 10 soalan saja berkaitan kuis chapter 1 dan chapter 2. Nanti saya akan maklumkan. Okey, terima kasih semua. Sekian yang attendant. Okey, sekejap.